In this video, we're going to talk about topic 5.2, which is applications of matrices and determinants, and we're going to be using something called Cramer's rule. So this is another way to use something that is called a matrix to calculate a system of equations. So we're going to answer the question, how to use Cramer's rule to solve a systems of equations. And our two I can statements are I can calculate the 2x2, determinant of a 2x2 and a 3x3 matrix, and I can solve a system using Cramer's rule. So a matrix is basically it looks kind of like a box. It's something that we can use. It's a kind of a shortcut to doing some calculations. So we write it in, you'll see a matrix written as these brackets. And then when we want to convert it to the determinant, we put these bars on it. So the determinant will calculate the value of this matrix. And matrices are used actually in computer graphics. This is actually the mathematics behind computer graphics. So this is kind of just dipping our toe into that and getting to see something a little bit different. So to calculate the value of a matrix, or the determinant of a matrix, we multiply the diagonal. So it would be A times D. And then we subtract that from multiplying the up diagonal, which is C times B. So we can do this on a 2x2, or we can do it on a 3x3. So when we do this on a 3x3, we start with the top we start with the top diagonals, and on the top diagonals you have to add, and then on the up diagonals there, or down diagonals, up diagonals, you have to subtract. And subtract is just basically a fancy way. Think about it if I distributed there to switch the signs. All right, so let's just practice the 2x2s and the 3x3s here. So again, I'm going to be a little bit lazy. I'm just going to put my little bars around it. That's now the determinant. When you write it down on your paper initially, you could just write it that way. And I'm going to go down the first diagonal, and I'm going to multiply 2 times 2. Then I'm going to use the subtract operation always, and I'm going to multiply the up diagonal, which is 1 times -3. And then 2 times 2 is 4. -1 times -3 is +3. So the value of my determinant is 7. All right, we're going to try this again. I'm going to make my absolute value bars there. Or not absolute, my determinant bars. They're not absolute value bars. I'm not going to show as much work on this one. So I'm multiplying my down diagonal, and I get 2 times 2 is 4. I know I subtract. I multiply my up diagonal. I get 4 times 1 is 4. So the value of this determinant is 0. In example 3, I'm going to put my determinant bars there. I'm going to multiply my down diagonal, which is 0 times 4, which is 0. And then I'm going to multiply my up diagonal. I think I'm going to show work on that one. So that would be 2 times 3 halves, which the 2's would cancel. So I end up with 0 minus 3, or just -3. So on a 3x3 matrix, this is a little bit more different. I'm always going to do my down diagonals first. So I'm going to do this diagonal. Oh, actually, before I even do that, I have to rewrite. So I'm going to start by rewriting my first 2 columns. So 2, 4, 3, and it's very important that you keep everything lined up. Then I'm going to multiply my down diagonal first. So I'm going to go down all my down diagonals. So I have 2 times 1 times -2 is going to give me -4. And then -1 times 0 times 3 is going to be 0. And then -3 times 4 times -4 is going to give me +48. And then when I'm writing this down, I keep the sign because I am adding. So keep sign because we are adding. Okay, so I'm just going to write it down here. So we've got -4 plus 0 plus 48. Now I'm going to do the up diagonals. So I'm going to start by multiplying 3 times 1 times -3, and that would give me -9. And then -4 times 0 times 2 would give me 0. And then -2 times 4 times -1 gives me 8. And because up here I am supposed to subtract, what I'm really going to do is I'm going to change the sign. So I'm going to go +9 -0 -8. And then when I add all of those up, I end up with 45. So let's try that one more time here. So I'm going to start by recopying my first two columns. So 10, 2, 0, -2, -12, -7. All right, I'm going to go my down diagonals first. So 10 times -12 times -2 is 240. -2 times 4 times 0 is 0. 3 times 2 times -7 is -42. And then my up diagonal, 0 times -12 times 3 is 0. -7 times 4 times 10 is -280. And then -2 times 2 times -2 would be +8. So, and I forgot to write down my originals here, or my down diagonal. So my down diagonal, I keep the sign, so 240 plus 0 minus 42. My up diagonal, I change the sign, so -0 plus 280 minus 8. And then when I add all of that up, I end up with 470.